right, class, I thought you might like to learn a little bit about 3D printing, because the college has a $35,000 3D printer, which is pretty nifty in the physics department. So I thought you'd like to hear a little bit about it. Basically, the way it works is if you try to imagine using a glue gun or a cake decorating tube where you're dispensing material. In this case, we're going to dispense a liquid plastic. And imagine a print head, and it's basically printing back and forth, dropping a layer of this plastic material 1/10,000th of an inch thick. And then it comes back and just cross hatches in the opposite way. So for example, here's a cell phone cover that we printed with a little skull face on it. I don't know how well you can see that on this camera. But basically, it just goes back and forth at a diagonal. If you look at this, it's actually going to print diagonally all the way across, up and down, up and down, up and down, like you're coloring in a box on a crayon. And then it'll go diagonally the opposite way and print to make it stronger. And then it just builds up the layers. Now that's an easy piece. What if you have a piece like this? That it's a dice, it's a die, pair of dice, and these are actually hollow inside, and you'll see they've got holes in them. You say, well, okay, I understand printing in layers, but how did it print the top one? How does it print on air? Because this top layer, inside, there's nothing. So the way that's done is you actually have two print heads. One is printing the white plastic material. The other one, where the air space is printing with this block material. And then that material, once you're done with the object, we're going to put the whole object, put it in a bath of chemical, and then that black material dissolves. And that way you have the air space inside. Here's another idea of a cell phone cover, and it has little gears that spin. And this was printed on a 3D printer as well. Here's my favorite. This is a clock, a plastic clock, but all the gears turn. Let me get it up real close so you can see that if I turn the gears, the clock face actually tells you the time. And if you look at it from the side, you see all the gears in there. And like I said, this was printed layer by layer with the red plastic in this case, and in between where all this airspace is, it's printing little layers of this black kind of material, and then at the end you get kind of this big brick of stuff, and we drop it in this bath, and then all the black material dissolves, and you're left with a fantastic component. I mean, it's going to change everything, this 3D printing. Not just printing parts for manufacturing, but you can print, think about instead of printing with plastic, you're printing with metal, liquid metal, or any glass. You could make all kinds of things. So it kind of depends, but here's what the material looks like. There's a little spool, actually it's a huge spool, this is just a piece of it, of the white plastic material that comes down the print head and melts into all these positions on the object. And then the black material, this other stuff is not actually plastic. It's some other composite of chemicals. This is what they call the supporting material. So when you need to print something that requires support, like the top part of some of these gears can't print in thin air, it has to print on top of something, so it prints that in between. So it's a very interesting process. I thought you'd get a kick out of it. The price of these printers is coming down. The art department actually owns one. I think it's only a $1,000 printer, but of course it's much more limited in what you can do. And over time, these prices will come down, and it'll be much more reasonable. But I thought you'd get a kick out of it. So if you have any questions, Google 3D printing and watch some of the videos. There's a lot of cool things out there. And like I said, we have some objects here that we can show you and demonstrate. And if you're in the physics, they actually use it sometimes to print some of the pieces and equipment that they use in the physics lab. All right, y'all, have a good day. And as always, contact me if you're having any problems. Take care.